So at this point, you should probably feel fairly comfortable with the diagram of the heart, but let me go ahead and label a few things just to make sure we're all on the same page. So blood flows from the right atrium to the right ventricle. It then goes to the lungs, and then from the left atrium to the left ventricle. So that's usually the flow of blood. Now, one of the things that keeps the blood flowing in the right direction is the valves. So two of the valves I'm going to name, I'm giving them new names, something slightly different from what we've been referring to them by. So these are the atrioventricular valves, and you can take a guess as to which ones I'm referring to. Atrioventricular valves are the two valves between the atria and the ventricles. So one will be the tricuspid and the other the mitral valve. And then just to orientate us, this is the tricuspid valve and this is the mitral valve. So the atrioventricular valves, if you look at them, they're both kind of facing downwards. So one of the two things you might be wondering is, how is that they aren't just flopping back and forth? So these valves in particular, they have a very interesting strategy. They're actually tethered to the walls, and I kind of drew that there. So they're held down there like that. They have on the other end of these tethers a little muscle, and this makes perfect sense if you think about it. The ventricles are very strong, right? So we know the ventricles are really, really strong. If the ventricles are squeezing, there's a good chance the blood is going to shoot up in any direction it can go. So it's going to go back perhaps through the mitral valve if it can go there, or it might go through that tricuspid valve if it could go there. The reason that it won't is that these papillary muscles are basically sending out little lifelines to keep the valve from flipping backwards. So these chordae tendineae, these cords, are important for that reason. They keep the valve from flipping backwards. So these are all the chordae tendineae, and these are the papillary muscles. These are particularly important for when you're trying to make sure that ventricles don't screw up the valves. So let's move our attention to another area. Let's focus on this right here, which is the interventricular septum. The one thing I want to point out, which is fairly obvious when you look at it, you might think you didn't really have to say that, it's pretty obvious, but that this area is really thin, and then that this area is really thick by comparison, right? So the two areas are not equal in size. This is much thicker. The reason I bring that up is because the first area that I kind of colored in blue, that's the membranous part. It's literally like a membrane. The bottom part, the red part, that's the muscular part. So this is a strong muscular part. And you have two different areas in that interventricular septum, the wall between the ventricles. So one of the interesting things about the blue part in particular is that a lot of babies are born with holes in that membrane. And by a lot, I don't mean a majority by any means, but one of the most common defects would be that you would have a communication problem between those two. So blood could flow between these holes here and go from one ventricle to another, and that's a big problem. So that is called a VSD, and you might hear that term in some point. So I just want to point out where that happens. And VSD stands for ventricular septal defect, and that makes sense because it's blood going between the two ventricles from the septal, which just stands for wall. So a VSD is common in the membranous part more so than in the muscular part. And then finally, just as a refresher, I'm not going to label anything on the diagram, I just have this little drawing here for you. It should be something you already know, but the heart muscle then has three layers. So on the outside you have the endocardium, and the endocardium is very similar in many ways to the inner lining of the blood vessels. Next would be the myocardium, and myo means muscle. So the myocardium is where all of the contractile muscle is going to be. That's where a lot of the work is going to be done. And it's also where a lot of energy is being used up. So when the heart needs oxygen, it's usually the myocardium. And then the outside layer is the pericardium. And the pericardium actually has two layers. So the first is the visceral pericardium, and the other is the parietal pericardium. And this concludes Unit 1, Lecture 5.